All right, today's lesson is going to be on Graham's Law. And so in order to look at Graham's Law, let's talk about two different vocabulary terms. Let's start with diffusion. This is a term that you spent a lot of time in biology talking about. Diffusion is the even distribution of gas particles Now, diffusion doesn't always involve gas particles, but in terms of Graham's law, it is going to be just the gas particles. And you talked about diffusion in biology and spent a whole lot of time on it. And we learned that molecules move from an area of high concentration to low concentration through the process of diffusion. Graham's law is specifically for gas particles. Effusion is the movement of a gas through through a hole. So let's say I'm driving home today and I run over a nail with the tire of my car. So I now have a hole in my tire of my car. What's going to happen? The air is going to move out of the tire, all right? So that is effusion, the movement of a gas through a hole. And we are moving from, again, high to low concentration. Okay. Kinetic energy is going to be determined by temperature. We've seen this a couple of times, okay? This is a concept that just keeps coming up over and over and over again. Temperature and kinetic energy. All right, temperature is the measure of the average kinetic energy a substance has. So the higher the temperature, the more kinetic energy. If my temperature and kinetic energy stay the same, heavier molecules move more slowly. All right. Now that kind of makes sense intrinsically. If we were to think about this in terms of a bowling ball, all right, I give you say a 5-pound bowling ball and a 20-pound ball. And I tell you to roll it as fast as you possibly can get it to roll. All right, which one are you going to be able to get to roll quicker? The 5 or the 20-pound? Right, the 5. Why? Because it's lighter. The heavier one is going to go more slowly. All right. So Graham's law is defined as the rate of diffusion is inversely related to the square root of its molar mass. All right, so let's see if we can't figure out what that means, okay? So an inversely related, and we have a square root, and we're talking about diffusion and molar mass. So essentially, the rate of substance A over the rate of substance B is going to equal the square root of the inverse. So the molar mass of B will now be on top, and the molar mass of A will be on bottom. So let us determine the relative rate of diffusion for krypton and bromine. So what I'm going to do here, in order to give myself a whole number, I'm going to look at my periodic table, all right, and I'm going to find krypton, which is 83.80. Now, bromine is 79.9, but we know bromine is diatomic, so there are two bromines. So bromine is the heavier one. So the rate of krypton over the rate of bromine, which is diatomic, is going to equal 79.9 times 2 is 159.8 for the molar mass of bromine, and the molar mass of krypton is going to be 83.80. Excuse me. And we're going to take the square root. So when I plug this into my calculator, I get 1.38. So what this means is krypton moves 1.38 times faster than bromine. So that's how we would write it. Krypton diffuses 1.38 times faster than bromine. And that makes sense because krypton is the lighter one, so it is going to move faster. All right. An unknown gas diffuses 4 times faster than oxygen. Find its molar mass. All right, so when we look at this problem, we have to look at a couple of things. First of all, the unknown is moving faster than oxygen. So that means it is going to be lighter than the oxygen. All right, this is a whole number. So up in my top problem here, how did I get a whole number? I put the heavier one on top and the lighter one on bottom. So since I have a whole number here, again, my heavier is going to have to go on top. And I know oxygen is heavier. All right. And when I look at my periodic table, oxygen has a mass of 16. There are 2 oxygens. So the mass of oxygen is 32. Divided by the molar mass of my unknown. So this is the inverse. So the rate of the unknown, which I'm just going to put UNK, over the rate of oxygen is the inverse of their molar masses. So I know the rate, this total rate is 4. So 4 equals the square root of 32 over the molar mass of the unknown. Now, how am I going to get rid of this square root? I need to square both sides. So 4 squared now equals 32 divided by the molar mass of the unknown. 4 squared is 16. And when I solve for this denominator, I find the molar mass of the unknown is 2.0 grams per mole.